Okay, so sometimes we are given an equation in which the x and y are not separated in a sense that y is on the left side and x is on the right side. Okay? We can have something like x squared plus y squared equals 18. So what should we do if we are supposed to find the derivative of such function? What do you remember from last time? Or did you even cover implicit differentiation? Okay, but anything that you can suggest, what do you think should we do? Any solution or possible solution? Transpose. Okay, so maybe we can keep the y squared and then we can change it to 18x minus x squared. And then we have y is plus or minus the square root of 18 minus x squared. Okay, so that could be a possible solution, but as you can see, we ended up with something that is a positive or a negative. At the same time, there is a square root. So implicit differentiation is introduced so that we will not be differentiating expressions such as y equals plus or minus the square root of 18 minus x squared. Okay, so for today, we will discuss how implicit differentiation is done in functions or equations rather, such as x squared plus y squared equals 18. And you can immediately anticipate implicit differentiation the moment you see that x and y are on the same side or y having an exponent more than 1. Usually equations are like y is equal to, okay, y has an exponent 1, but in this case we have y squared. In other cases we will have y cubed. Okay, so how do we perform implicit differentiation? So x squared plus y squared is equal to 18. Now in the problem, by the way, before I forget, there is a note that the differentiation should be done with respect to x, meaning to say that the independent variable is x. Without that statement, we don't know which one is the dependent and which one is the independent variable. But if I say with respect to x, that means the derivative that we want is a dy over dx. Because otherwise, we don't know if we have to find dy over dx or dx over dy, in which the second one is with respect to y. Okay, so now with respect to x means we are sure that we're looking for dy over dx. Okay, now to easily understand this, remember when we get the derivative of y equals to x plus 4, how do we write the derivative of y? Or how do we proceed? The other side is 2, definitely. But how do we write our solution? Dy over dx. So when we get the derivative of y, we write dy over dx. So this will be important once we go to the example x squared plus y squared equals 18. So here is what we can do. For all the x's, differentiate as normal. What is the derivative of x squared? 2x. For the case of the y, differentiate as if it is a normal x, so y squared will be 2y, and then apply the chain rule. You have the y that's supposed to be or to become dy over dx. Remember, from y squared, 2 goes down, y raised to 1, but you have to indicate the derivative of y, which is dy over dx. Follow? And then equals, differentiate 18 as usual, 0. Okay, so that is our first step. After this, Note that your goal is to get the derivative, so your goal is to get the dy over dx. You need to isolate dy over dx. So that means you have 2y dy over dx, and then the 2x will be transposed to the other side, that is basically 0 minus 2x or negative 2x. And again, focus on the goal. You want dy over dx, so you have to divide both sides by 2y. So 2y and 2y will cancel. So you have dy over dx on the left side. 2 or negative 2 and 2 becomes negative 1. So we have negative x over y. Okay, so in this case, if we apply implicit differentiation, to write y on the other side is okay. You can leave it on the right side. Okay, so dy over dx is equal to negative x over y. So that's how we perform implicit differentiation. Any question? Are you able to follow? Okay, so we continue with example number 2. This time, still looks similar to the first one. We have x squared plus 9y squared equals 18, and then maybe a little different because we have an xy. In the previous example, it's just 18, so the derivative of a constant is 0. Okay, so again, we perform the process. So solution, the derivative of x squared, taken as usual, is 2x. Now, 9y squared, 18y, and every time we differentiate something with y, we have the dy over dx. Okay. On the right side, it says 18xy. How do we differentiate 18xy? Just 18? 18x is 18, but 18xy is different. 18 over y? Okay. Kulang. Okay, but this is how I want you to see it. And then what's your suggestion? 18 dy dx. Close. Okay. But when you see an x and y together, the operation involved is multiplication, right? And whenever we differentiate a product of two expressions, there is a rule that we can use, the product rule. So if we see an x and y, we have to apply the product rule. Okay, so for the meantime, you can leave the 18 outside of the x and y and perform the derivative on xy using the product rule. So in the product rule, you have the first and then you have the second, right? So this will become first and then dy over dx, right? The first and then derivative of the second plus the second derivative of the first is 1. So it's just y times 1, which is equal to y. And then you can now distribute the 18. So first, you just copy 2x, 18y, dy over dx. And then 18 goes to x dy over dx. 18 goes to y, which is 18y. Question? In 1, because the x, when you differentiate x, it's like 1x. So derivative of 1x is 1. Parang kung 2x, derivative is 2. 3x, derivative is 3. So kung x, it's equal to 1. Yan. Okay? So this is a note. And then we proceed. Okay, again, your goal is to get dy over dx. You always isolate the one that you want to get. So make sure to place all the expressions or terms with dy over dx on one side and the rest on the other side. So I can write this as 18y dy over dx what should I do? What goes to the left side? If I have to isolate dy over dx, well, 2x will go to the other side, but to the left side, what will be added or subtracted? Minus 18x dy over dx equals 18y minus 2x. Okay, did you understand the transformation? So all the dy dx on the left side, without the dy over dx, they will go to the right side. And then use a proper operation. Addition becomes subtraction, subtraction becomes addition. Now the moment you group all the dy over dx, you have to bring out, that means to factor out the dy over dx. So this becomes dy over dx. So the first term becomes 18y, and the second term is 18x. And you have 18y minus 2x on the right side. And finally, you have to eliminate or cancel 18y minus 18x. So you divide by 18y minus 18x. And then cancel and cancel. So this is your dy over dx. In some cases, you can further simplify, okay, but never cancel things like this. You cannot do that. Okay, cancellation can only be done on a product, so you cannot cancel 18y and 18y. But what can we do? Okay, all numbers are divisible by 2. So technically, what will happen here is we factor out the 2 on the numerator. It becomes 9y minus x. 2 in the denominator becomes 9y minus 9x. And then you cancel 2 and 2. So you have final answer 9y minus x over 9y minus 9x. Note that 9 cannot be cancelled because the x in the numerator has coefficient 1 or negative 1. So this is our dy over dx. Again, y can be written on the right side. No need to isolate. Okay? So that's how you do it when there is an expression containing the product, or maybe x, or even y squared, or y cubed, and so on. Questions? Okay, practice first. Letter E. Okay, please do letter E. So letter E is x squared minus 2x plus y squared plus 2y is equal to 23. So solution: 2x minus 2 plus 2y dy dx plus 2 dy dx equals 0. Okay, and then isolate. So 2y dy dx plus 2 dy over dx equals negative 2x plus 2. Tama? And then factor out dy dx. So this is always the pattern: 2y plus 2 and then equals negative 2x plus 2 divided by 2y plus 2, and then you have 2y plus 2. So cancel. Dy over dx is, okay, let's write it first. 2x plus 2, 2y plus 2. In simplest form, x plus 1 over y plus 1. Okay? And you can, well, not required, but you can see it as well as 1 minus x, y plus 1. And there are many forms. different forms. Okay, so I hope that is clear. So that's how we do implicit differentiation.